Good afternoon, students. Today we are going to talk about nitrogen and its compound. And as you all know, nitrogen exists in air as a diatomic molecule. This is a simple diagram showing how nitrogen is obtained using over water method. So in this diagram, things that you need to take note of, the first thing is the function of this concentrated potassium hydroxide. Concentration potassium hydroxide is used to absorb excess carbon dioxide, and you can be asked in an exam to write the equation that will occur at this point. So the equation that you are going to write, you write the equation between potassium hydroxide and carbon dioxide. Potassium hydroxide plus carbon dioxide, which you are going to get potassium hydrogen carbonate. The equation is the symbol state of carbon dioxide is in gaseous state, this is in aqueous state, this is in aqueous state. So this equation is balanced. Another question that you can also be asked in this diagram is the function of aspirator. The aspirator allows air to circulate in the system. This aspirator allows air to circulate in the system. So another question is, what is the function of water entering the aspirator? The water enters the aspirator to displace the air inside the aspirator upward. The water displaces the air inside the aspirator upward. Another thing that you need to take note of, these copper tannins, the copper tannins are used to absorb oxygen. The copper tannins are used not to absorb, to remove excess oxygen. The copper tannins are used to remove excess oxygen. So you can also be asked to write the equation that will occur in the combustion tube. This is a combustion tube. The equation that you are going to write, you write the equation between copper and oxygen. You will write the equation between copper and oxygen. C plus oxygen get copper 2 oxide. This solid, gaseous state, this solid. So here is 2, here is 2. The equation is balanced. This is the equation that is going to occur in the combustion tube. So another thing that you need to know, you can also be asked, give the observation that is going to made, the observation that you are going to see in the combustion tube. So the observation is the black solids will turn to brown. The black solids of copper tannins will turn to brown. So copper is black in color, but when it combines with oxygen to form copper 2 oxide, it's brown. It is brown. This black. Copper is black while copper 2 oxide is brown. So that is the observation. Apart from concentrated potassium hydroxide, you can also use concentrated sodium hydroxide. You can also use concentrated sodium hydroxide. You can use concentrated sodium hydroxide. So the nitrogen obtained in this sector will contain some impurities. The nitrogen that will be obtained contains some impurities. Now let us look at some of the properties of nitrogen. We are going to start with the physical properties. One of the physical property of nitrogen is it is a colorless, odorless and tasteless gas. It is a colorless, odorless and tasteless gas. Second, almost insoluble in water, thus collected over water. It is it is almost insoluble in water, thus collected over water. That is another question that you can also be asked. Give the reason why. Maybe you are given this gas X. Give the reason why gas X is collected over water. Give the reason why gas X is collected over water. You are going to say it is almost insoluble in water. Another physical property, it has a boiling point of negative 196 degrees Celsius and melting point of negative 210 degrees Celsius. So let us look at the chemical properties of nitrogen. Chemical properties of nitrogen. 1. It does not support combustion and is not poisonous. It does not support combustion and it is not poisonous. So another chemical property, it reacts with hydrogen when heated to give ammonia gas. It reacts with hydrogen when heated to form ammonia gas. That is a simple equation that you can write. That is nitrogen plus hydrogen to form ammonia gas. So let us look at some of the uses of nitrogen. One of the uses of nitrogen, it is used in the manufacture of ammonia in the Haber process. Nitrogen is used in the manufacture of ammonia in the Haber process. Another thing, it is used as a refrigerant, e.g. in storage of semen for artificial insemination. It is used as a refrigerant, e.g. in storage of semen for artificial insemination. The reason why it is used as a refrigerant in storage of semen, this is because it has a low boiling point of negative 196 degrees Celsius. A low boiling point of negative 196 degrees Celsius. Now let us look at some of the laboratory preparation of nitrogen. The laboratory preparation of nitrogen. This is a simple setup for laboratory preparation of nitrogen gas. Laboratory preparation of nitrogen gas. This is ammonium chloride and sodium nitrate. Nitrate or nitrite?
Nitrite.
Nitrite. They are reacting in the presence of heat to form nitrogen gas. So the thing that you need to know from that diagram or from that symbol setup is the equation that is going to occur when ammonium chloride and sodium nitrite react. So here is the equation that is going to occur. Sodium nitrite plus ammonium chloride to form, they are going to form ammonium nitrite. Ammonium nitrite plus sodium chloride. So the equation must be balanced. The equation must be balanced. And here in this equation, in this scenario, the equation balances itself. So the state symbols is aqueous, both are just aqueous. And this type of equation is a thermal dissociation equation, whereby these compounds are going to exchange the radicals to form ammonium nitrite. And this ammonium nitrite is unstable, so it will decompose to form ammonium nitrite is going to decompose to form nitrogen and steam. Ammonium nitrite is going to decompose to form nitrogen and steam. ammonium nitrate is going to decompose to form nitrogen and steam. Steam is just water but in gaseous state. Ammonium nitrate is going to decompose to form nitrogen and steam. It's going to decompose to form nitrogen and steam. So the nitrogen obtained from this reaction is less than air, than that isolated from air. This because it does not contain impurities. It does not contain impurities. So now let us look at some of the oxides of nitrogen. The oxides of nitrogen are nitrogen 1 oxide, nitrogen 2 oxide, and nitrogen 4 oxide. So nitrogen 1 oxide, we are going to talk about nitrogen 1 oxide. We are going to talk about nitrogen 1 oxide. Nitrogen 1 oxide. This nitrogen 1 oxide. Nitrogen 1 oxide. So the preparation of nitrogen 1 oxide, it is prepared by heating ammonium nitrate. This nitrogen 1 oxide is prepared by heating ammonium nitrate. It is prepared by heating ammonium nitrate. So when you heat ammonium nitrate, it's going to form nitrogen 1 oxide plus water. This is the equation that you are going to write. Ammonium nitrate are going to heat it to form nitrogen 1 oxide plus water, liquid state, gaseous state, aqueous state. So this nitrogen 1 oxide is obtained by heating ammonium nitrate to form that's nitrogen 1 oxide and water. Nitrogen 1 oxide and water. So ammonium nitrate melts and decomposes on heating to form that nitrogen 1 oxide and water. But this water is water in gaseous state. So by water in gaseous state, that is steam. Nitrogen 1 oxide is a colorless gas with a pleasant smell, and it is slightly less than air. Nitrogen 1 oxide being slightly less than air, you can use that method that you are taught in Form 1 to collect it. Hope you know it. Then it is fairly soluble in cold water, but it is insoluble in warm water. This is a point that you need to take note of. It is fairly soluble in cold water, but insoluble in warm water. Soluble in cold water, but insoluble in warm water. So for this reason, it is usually collected over warm water. It is collected over warm water. Now, if you are asked to give the difference between nitrogen 1 oxide and nitrogen 2 oxide, you can give your difference based on the method of collecting. You will say that nitrogen 1 oxide, it is collected over warm water, while nitrogen 2 oxide, it is collected over cold water. So then nitrogen 1 oxide, it relights a glowing splint. It relights a glowing splint. Nitrogen 1 oxide relights a glowing splint. And this is how nitrogen 1 oxide relights a glowing splint. So if you take a glowing splint and you light in a gas jar containing nitrogen 1 oxide, the glowing splint, the heat from the glowing splint is going to dissociate nitrogen 1 oxide into nitrogen and oxygen. So this oxygen is the one that is responsible for relighting the glowing splint. This is how nitrogen 1 oxide relights a glowing splint. This is the equation on how nitrogen 1 oxide lights the glowing spleen. If you are asked to explain, you just simply say the heat from the glowing spleen dissociates nitrogen 1 oxide into nitrogen and oxygen. The oxygen produced is the one that is responsible for lighting the glowing spleen and will be given a mark. In that case, it can be 1 mark or a half mark. So another thing that we need to talk about is the uses of nitrogen 1 oxide. The uses of nitrogen 1 oxide. So, nitrogen 1 oxide is used in production of flame for analytical work. Then it's used as an oxidizer in car engines or rockets. It is used as an oxidizer in racing car engines or rockets. This oxidizer, if ama kuna wajamaa wanacheza, some people wanapenda kucheza some games like motorbike games. Unaona kuna mahali una press hapo kwa mafuta, then hiyo motorbike inakimbia mbio sana. That is nitrogen monoxide is used in oxidizing the engine, thus making the motorcycle to move in a very high speed. So next, let us talk about nitrogen trioxide. Nitrogen trioxide, just talk something small about nitrogen trioxide. Nitrogen trioxide, we need to draw a diagram. Yes, service. So this is a setup for preparing a nitrogen 2 oxide. Nitrogen 2 oxide. Here is dilute nitric 5 acid. Dilute nitric 5 acid. Then here copper tannins. And copper tannins. So here we are going to get nitrogen 2 oxide, which is a gas. Nitrogen 2 oxide. So another thing, this is cold water. It must be cold water. It must be cold water. Cold water. If you use warm water, it will dissolve in. So this nitrogen trioxide is produced when nitric 5 acid and copper tannins react. The equation is nitric 5 acid as copper tannins. We are going to get copper 2 nitrate plus water plus nitrogen trioxide. This liquid, copper 2 nitrate, this solid seconds. So you must balance the equation. So here is 3. Here is 3, 8 for copper nitrate. Copper nitrate is 3. Copper nitrate. Equation of copper nitrate is 3. Here is 4. Then here is 2. The equation is well balanced. So this equation is, you should also put it in your mind because it is commonly examined in chemistry exams. So nitrogen 2 oxide, let us look at some of the properties. Nitrogen 2 oxide is a colorless gas, and it is slightly soluble in water and has no effect on moist litmus paper. This nitrogen peroxide has no effect on moist litmus paper, and this gives it a property which is known as, this nitrogen peroxide has a unique property. It is a neutral gas because it has no effect on a litmus paper. It has no effect on a litmus paper. So when nitrogen peroxide comes in contact with iron 2 sulfate, it is going to form a complex compound which is called nitroso-iron 2 sulfate. Nitroso-iron 2 sulfate. When nitrogen 2 oxide gas combines with iron sulfate, it forms a complex compound known as nitroso-iron 2 sulfate. So the equation is this is how you are going to write the equation: iron 2 sulfate plus nitrogen peroxide form a complex compound known as nitroso-iron 2 sulfate. Nitroso-iron 2 sulfate. This is the iron 2 sulfate. That is the complex compound that is formed when iron 2 sulfate and nitrogen 2 oxide, nitrogen 2 oxide reacts. They form that complex compound. So when exposed to air, this nitrogen 2 oxide, when you expose it in air, it is readily oxidized by oxygen. It is readily oxidized by oxygen to form a red-brown fume of nitrogen 4 oxide. This nitrogen peroxide, when you expose it on air or in air, it forms nitrogen 4 oxide. It will form nitrogen 4 oxide. Nitrogen peroxide, when you expose it in air, it forms nitrogen 4 oxide. Must balance the equation: nitrogen peroxide, this is oxygen, put here 2, let's see, it's gas, they are both gases. If we balance the equation, how is the equation going to be? Let's see. 3 oxygen, 2 oxygen. If we put here 2, we are going to have 4 oxygen. If we put here 3, that is 6 oxygen. 3, here 2. Here 3. Let's see, 3 nitrogen, 3 nitrogen. 6 oxygen, 3 oxygen. That is 5 oxygen. Let's see how we can balance this equation. Let's try to reason out. How are we going to balance this equation? Let's reason. How are we going to balance it? Or you'll balance on your own. This equation, it can be balanced. Or you can use fractions to balance. If we use fractions to balance, if we put here half, we are going to have 2 oxygen. Let's see, a half. You can also use fractions to balance the equation. Half, now that is 2 oxygen, 2 oxygen. The equation is balanced. It is true, the equation is balanced. So it's all about just reasoning. Yes. Now that is the test for nitrogen 2 oxide. Let me repeat the test of nitrogen 2 oxide. You will first expose the gas into air. It will readily be oxidized by oxygen to form nitrogen 4 oxide, and the nitrogen 4 oxide that will be formed, it is a red brown fume red brown fume, that nitrogen oxide, red brown fume, and that is the test for nitrogen oxide. We shall meet in the next subtopic in this nitrogen and its compound. Thank you.